We will be highlighting NASA Develop and specifically the Georgia node. So we're really excited to hear a little bit more about the program and the project that they worked on these past 10 weeks. And I know a lot of y'all in the audience are some Develop alumni, so that's really cool. The connection is always strong with developers. So we're really excited to get this underway, and I'll go ahead and hand it over to the Georgia Fellow, Crystal.
Hello. Thank you for having me, guys. I'll go ahead and share my screen. Okay, can you all see that?
Yep.
Alrighty, I'll go ahead and get started. I'm just going to introduce our Develop program for those who don't know what it is. For those alumni who are out there, would love to hear from you afterwards as well. But I am Crystal. I am the current Georgia Fellow, even though we are currently remote. So I have never actually been to Georgia, but hope to someday. So let's try and get started here. So the NASA Develop program is just part of the NASA Applied Sciences division. The NASA Applied Sciences really works to try and partner with public or private organizations, really doing innovation with NASA Earth science, trying to spread the love of NASA, just really supporting environmental decision-making amongst community members, community groups, demonstrating the practical benefits of Earth science from NASA data in the real world to really improve the quality of life and help with environmental issues. There are three groups within NASA Applied Sciences. There's the RSET group, who does all the trainings, Servier, who works internationally, and NASA Develop, which is us, the capacity building division. All three of those groups do projects within our 8 application areas. So all Develop projects fall within one of these: the food security and agriculture projects, ecological forecasting, water resources, energy, urban development, transportation and infrastructure, health and air quality, and disasters. So I mentioned that Develop is the capacity building division, and that capacity building goes both ways. We are the bridge between NASA Earth science and society. So we have our participants who are really growing their own capacity, learning how to use NASA measurements and GIS and remote sensing, but we're also working directly with community groups, and we're trying to help them learn how to implement NASA products into their own decision-making. So we're building capacity on both sides. That's sort of our whole goal. Here's just a fun side of all of the NASA satellites and instruments that you could potentially use in a develop project. There are a whole bunch of them, and it's all open source, so we want to learn how to use those. So who can participate in Develop? We have our participants, who can be recent grads, military personnel, students, or transitioning professionals. We also have our scientific advisors who really support our team members in those projects. At Georgia, you already know our science advisors. That's Dr. Madden and Sergio Bernardes. So we're really happy to have them working with this project. And then the third wing of the Develop program is our decision makers. So those can be state or local governments, federal agencies, NGOs, or even international partners. Now, each Develop project takes 10 weeks, and there's about 60 of them per year. They all integrate NASA Earth observations and are directed towards community concerns about environmental issues. So it is a real applied science problem that the team works on from start to finish. They are hoping to enhance decision-making using NASA Earth observations. It's centered in one of those 8 application areas, and it's completed by interdisciplinary teams. 4 participants from all different skill levels, backgrounds, from different locations around America, or even international students. And at the end, they have this awesome product with lots of deliverables, because another one of our goals is to try and share like science with the public. So the team works on a poster or a presentation, a technical write-up. They share the shape files that they've made. Sometimes they make codes and tutorials, or even a video that can be displayed to the public. I'm going to highlight a couple fun recent projects. This is one completed in Boston, and it was talking about flood events related to beaver dams, which you wouldn't have even thought of, but that can be done with NASA Earth observations. And here was one about urban heat and how that affects human health. And that was done in Philadelphia. The team created a heat vulnerability index, and that is actually displayed on Philadelphia's website for the public. So the benefits of Develop for the participants are really to build your scientific and technical skills, but also your own personal development, how you communicate, your confidence, and then your professional development and networking opportunities, working with NASA scientists and science advisors and partner organizations and your team members. If you are interested, you are eligible if you're over the age of 18, have a minimum GPA of 3.0 or greater. You can be a current student, recent grad, early career professional, or transitioning professional, and all backgrounds are welcome. We have a lot of STEM field majors, but we also have had urban planning, architecture, biology, ecology, coding people, all kinds of different backgrounds. And as I said, we can accept foreign people into our teams if you are at a regional location like the Georgia office. And those are only 10 weeks long. There's 3 of them per year for our projects. And we have 11 offices around the country. I wanted to throw this up here just to point out that one of them is in Athens, although we are remote right now, so you could technically work at any office really easily. So if you're interested in applying, the next one that is open is our summer 2021 application, with applications opening in January 18th through February 26th. And that will start on June 7th, 2021. You can also follow us on social media. And if you have any questions or any other comments or points of interest, you can check out our website or email us at the link that is on our website. But with that, I will go ahead and pass it off to our current Develop team, who has just finished their 10-week project. We're very excited to hear from them. I think you guys will like it a lot. And team, take it away.
Thank you, Crystal. I will go ahead and share my screen. Alrighty. I'll see this okay?
Yes.
Looks good.
Alrighty, thank you. Well, hello everyone. My name is Madison Bradley, and this is Jennifer Gallucci, Jonathan Moallen, Erika Munshi, and we are the Africa Food Security and Agriculture team. And we're excited to tell you about the work we've done over the past 10 weeks, exploring how NASA Earth observations can be used to identify drivers of human-elephant conflict in the Kavango-Zambezi area of Southern Africa.
Our study area encompasses conservation lands in 5 African countries, including Angola, Botswana, Namibia, Zambia, and Zimbabwe, as shown in our map here. In this region, it's estimated that 75% of the continent's African elephant population cohabits with more than 3 million people. Our analysis focused on 2 regions within the Kavango-Zambezi area, which were Victoria Falls in Zimbabwe and the eastern panhandle of the Okavango Delta in Botswana.
As our study area consisted of 2 regions, we had 2 separate project partners with similar goals. Connected Conservation, headquartered in South Africa, focuses on biodiversity conservation and environmental, social, and economic best practices centered around Victoria Falls. Similarly, the EcoExist project aims to foster coexistence between elephants and people in Botswana.
As Jenny and Johnny mentioned, our project had 2 regions of focus, the first of which is Victoria Falls and the surrounding area in eastern Zimbabwe. Since 2017, our partners at Connected Conservation have been tracking 13 bull elephants in the region using GPS collars. These bulls are estimated to be between 20 and 30 years old and are considered to be bachelors, meaning that they have left their mothers but are not yet part of a new family group. In this stage of life, bulls are more likely to demonstrate aggressive behavior such as raiding crops or attacking locals or tourists, which makes them of particular interest for this project. In the photo here, you can see a snapshot of the collaring process. Connected Conservation uses a team of veterinarians and zoologists to carefully sedate and collar the bulls.
The second region of focus for our project was the eastern panhandle of the Okavango Delta in northern Botswana. On the east side of the Delta, approximately 18,000 African elephants and 16,000 people compete for resources, making this a human-elephant conflict hotspot. Researchers at the EcoExist project have been recording human-elephant conflict events since 2008 and have fitted more than 20 elephants from independent herds with GPS collars since 2014. Due to concerns for elephant habitat safety in northern Botswana, the team did not work directly with this data, but instead provided the resources for the EcoExist project to replicate our analysis with their elephant tracking data after the completion of this project.
Elephants are highly intelligent and travel across the landscape using distinct pathways that are remembered and followed by elephants for generations. As human population has increased in the Kavango-Zambezi area, human settlements and agricultural lands have expanded into free-ranging elephant movement pathways, leading to habitat fragmentation. Elephants' seasonal movements in search of food and water coincide with the ripening of crops between April and June, which poses a threat to human and elephant livelihoods. In Zimbabwe, a majority of the country's 1.5 million smallholder farmers are subsistence farmers. In Botswana, over 70% of the population depends on subsistence agriculture for their livelihoods. As elephants pass through agricultural fields and human settlements, they trample and raid crops, destroy property, and threaten residents, tainting human perceptions of elephants and complicating conservation efforts. Human-elephant encounters are inevitable due to the high elephant population density in the Kavango-Zambezi area. These encounters may result in the loss of both human and elephant lives.
To address these community concerns, the team had three primary objectives for this project, which were to analyze the relationship between elephant movement, vegetation health, and climate conditions, to develop reusable codes for partners to replicate our analysis as more elephant data becomes available in the future, and to create elephant kernel density heat maps to identify human-elephant conflict risk areas.
So to meet these project objectives, we use NASA Earth observations to access, process, and visualize our environmental factors in Google Earth Engine. We use surface reflectance data from the Landsat 8 Operational Land Imager, or OLI, to generate seasonal composite vegetation index images. We also use data from the Global Precipitation Measurement Core Observatory, or GPM, to quantify precipitation in our study area. Lastly, we use the Terra Climate dataset to generate surfaces for maximum temperature and drought. In addition to the Earth observations data, we incorporated the elephant GPS collar data from Connected Conservation, which covers the movement of 13 bull elephants from 2017 to 2020, as shown in the figure here. Because collaring elephants is a time and resource intensive process, elephants were added to the dataset at various time points, which created an interesting challenge for our project.
Using these data sources, the team designed a three-part methodology. Here is a brief overview, and we'll elaborate on each of these components in the coming slides. But to summarize, the team wrote two scripts that will allow our project partners to replicate our methods in the future. The first script was written in Google Earth Engine to access and analyze environmental data that is associated with elephant movement. And the second script uses R to clean and process elephant tracking data. The outputs of these scripts were combined in ArcGIS Pro, QGIS, and RStudio to create index images, kernel density heat maps, bivariate maps, and animations of elephant movements. The Google Earth Engine script allows the user to monitor changes in environmental conditions over time across the entire study region and in specific points of interest. The team analyzed 6-month periods between 2017 and 2020, corresponding to the wet and dry seasons, to highlight fluctuations in environmental conditions between the seasons. A few of our resulting output layers are depicted at the bottom of the slide here. Landsat imagery is corrected to remove clouds, shadows, and water, and composite images were created for each season. These composite images were processed to display two vegetation health indices, the Normalized Difference Vegetation Index, or NDVI, and the Soil Adjusted Vegetation Index, or SAVI. Both NDVI and SAVI measure vegetation greenness, but SAVI has an additional correction factor that reduces interference from bare soil in areas with sparse vegetation, such as agricultural fields, which were a main focus of this study. The difference in NDVI and SAVI values were also calculated to assess the change in vegetation health between the wet and dry seasons and over time. From Terra Climate, maximum temperature layers were extracted, and drought was quantified using Palmer's Drought Severity Index, or PDSI. And lastly, precipitation values were extracted from GPM.
In order to prepare our elephant GPS points, we created a script in RStudio to clean, process, and analyze the data. We also wrote code to create animations of elephant movement during each of the 6 seasons of study, one example of which is shown on this slide. The R script can be used to iteratively add new elephant tracking data to the existing data set, which will be a useful tool for our partners in the future. Once our GPS data was cleaned and processed, we imported it into QGIS to create kernel density heat maps. Finally, to synthesize the different elements of our project, we joined NDVI, SAVI, precipitation, and drought surfaces to our kernel density heat maps and created a series of bivariate maps to show the correlation between elephant movement and the different environmental variables.
We created several NDVI and SAVI images for our study period. In the end, we chose to display NDVI in our final results because NDVI values had a greater range and therefore greater visual contrast. Here are both displayed side by side for the 2019 dry season. NDVI values were generated for the wet and dry seasons across 3 years, resulting in 6 images. It's evident both visually through our images as well as in our statistics that 2019 was the driest year of our study period, and that from 2017 to 2019, we see a decline in vegetation health. In addition to creating individual NDVI and SAVI images, we analyzed the change in these variables as well. Areas colored with purple indicate a negative change in NDVI or decline in vegetation health, while green areas indicate a positive change in NDVI or increased vegetation health.
To analyze climate, we selected 2 representative points in Google Earth Engine to see PDSI, temperature, and precipitation values. The Earth Engine user has the flexibility of moving these points and generating similar charts to what you see here. So PDSI analyzes temperature and precipitation to estimate relative dryness. Monthly values take into consideration prior conditions up to 1 year, so this index is effective in identifying deviations from the norm. Key takeaway here is the negative PDSI values in 2019 signify a more severe drought, which aligns with the lower NDVI values we noted earlier. Severe droughts can diminish vegetation health and increase competition for resources between people and elephants. With data from TerraClimate, we created a chart of temperature through the study period as well. We leveraged this data to further understand if temperature is a significant human-elephant conflict risk factor. We found that generally speaking, elephants are more likely to travel when temperatures are lower. And here we see monthly precipitation rates. Comparing precipitation and PDSI charts, less than average rainfall during the wet season suggests a greater chance of severe drought through the subsequent dry season. Furthermore, lack of rainfall poses a threat to food security since farmers rely heavily on rain-fed irrigation.
In addition to the seasonal variation seen with our environmental variables, the movement of elephants with respect to season is a key element of our project. In this graph, you can see an example of what our elephant data look like spatially. Each color represents the GPS track for a specific bull. As you can see, there is significant overlap in the areas traversed by different elephants. This is suggestive of elephant hotspots. Identifying hotspots can facilitate better land management and elephant habitat conservation and gives us insight into elephant movement at different times of year. The symbology used in this graph represents seasonality, where dots are the dry season and triangles are the wet season. It appears that elephants increase their range in the wet season. This is particularly evident for bull 2 in orange, bull 8 in teal, and bull 13 in pink, where the triangle sections of the tracking paths extend well beyond the central patch in the middle. These animations show elephant movement during the wet and dry season respectively. As you can see, the geographic range for elephant movement appears to be larger during the wet season. This could indicate that certain seasonal drivers attract elephants to specific areas at different times of year.
We create kernel density maps for each of the 6 seasons studied to visualize how elephant movement patterns might change depending on the season and year, as well as to identify hotspots so elephants tend to congregate and revisit. Based on the kernel density maps for the 2018 and 2019 dry seasons, it appears elephants tend to congregate around greener vegetation and water sources during the dry season, without venturing far into agricultural areas for the most part. In these particular maps, many of the collared bulls enjoy an island in the Zambezi River, which provides plentiful water, food, and safety from humans. When comparing elephant movement during the wet season, another pattern emerged. During the wet season, elephants appeared to venture further from regular water sources when compared with the dry seasons. In the 2019 wet seasons, tracks shown in the lower right corner on the map are evidence of elephants venturing into agricultural areas. When elephants crop raid, they tend to move quickly as opposed to leisurely, spending time at the river, where they're safe from humans and will linger for longer periods of time. We created an animation displaying all NDVI and kernel density maps to enable easier comparison among them. In the animation, the expansion of the bull elephant's range in the wet seasons is particularly striking. Spots along the Zambezi River, particularly the island near Victoria Falls, appear to be hotspots for bull elephants during both the wet and dry seasons.
So to understand how elephant presence relates to our other environmental factors, we created a series of bivariate maps, one example of which is shown here. The map depicts the relationship between elephant presence and NDVI in the wet season of 2019. As you can see, during the wet season, NDVI values are high across the region, shown by the darker green areas. There isn't a particularly large area where there's both high kernel density and high NDVI, just that small section of dark blue near the river. This may be because elephants have ample access to healthy vegetation during the wet season, in which case NDVI may not be a significant driver of elephant movement. As Jenny mentioned, these movement patterns suggest that other factors may be drawing elephants closer to the river, such as safety and distance from human populated areas. In the dry season, however, we see lower NDVI values over the region generally and greater overlap between the areas of high NDVI and areas of high kernel density, which are indicated by the purple and dark blue patches. This suggests that during drought periods, we may be more likely to see elephants congregating in areas with relatively high vegetation health.
Conclusions drawn from our data analysis support the theory that elephants travel greater distances during the wet season and tend to congregate around water sources during the dry season. The Earth Engine Code quantified widespread increases in greenness and precipitation measurements in the wet season compared to dry. These observations suggest that crop raiding events are most likely to occur towards the end of the wet season, when crops are ready to be harvested and elephants are less stagnant. Future studies taking into account recorded crop raiding events can further support this theory. We also noted that the study area experienced a nearly 20% decrease in mean NDVI or vegetation health from 2017 to 2019, indicating strong drought conditions that may have had an impact on elephant movement.
This project will be continued into a second NASA developed project in the spring to build upon the preliminary conclusions drawn in this project. We recommend that the second term team utilizes high resolution planet imagery to create updated land use and land cover maps of the Kavango-Zambezi region. The first and second term products could then be combined in a predictive model to identify areas that will be more susceptible to human-elephant conflict in the future and can be used by our partners to inform land manager decisions to avoid further expansion of human settlements and agricultural lands into conflict zones. Furthermore, we suggest that future works analyze other proposed drivers of elephant movements, such as mating behavior, disturbance from bushfires, land surface temperature, distance to ephemeral water sources, and elephants' crop foraging preferences. High resolution imagery may also allow for the identification of cyanobacterial blooms to further understand elephant movement drivers. Overall, we expect the second term of this project to build upon the environmental indicators we have studied and examine the drivers of elephant movements and resulting human-elephant conflicts in greater detail. Now the team would like to thank all of the people who supported us through this project, including our partners at the EcoExist Project and Connected Conservation, our science advisors, and our Develop Fellow, Crystal Wespestad. And now we would like to offer this time for any questions you may have for the team.
Okay, we have about 5 minutes for questions, and then we'll head on to the concluding remarks. Well, thank you, NASA Develop. If anybody has any questions, please write them in the chat, or if you would like to speak, raise your hand and we will unmute you.
I just want to say that was a lot of very, very cool integration. So job well done. Just out of curiosity, since this is week 10, and y'all have already presented all your work to the partners, right?
Correct. Yeah.
Just out of curiosity, what was like the partner response?
I think they were happy with the results. I think we got some really good questions about, how they asked us how we thought the results could be integrated into land management. And it's great to sort of like think about that and the practical applications. It's a real focus of Develop. So we're excited that, our results could be, they've already made plans to present our results to their regional wildlife managers, which is really exciting. And our hope is that our project could be used as sort of a jumping off point to identify, drivers of elephant movement. And then the next term could really build upon that and build a predictive model. And I think being able to forecast future potential areas of human-elephant conflict is a real interest to our partners.
Great, thanks.
I see who is our Develop alumni here. Any hands raised for our Develop alumni? Nice. Oh, hey, Shelby.
So I have a question for the team. Okay, can I ask?
Take it away, Abhishek.
Yeah, so I don't know. First of all, I want to say this is one of the most comprehensive project I have seen at our node so far. I don't know. It's just one term work. You did just within one term, entire work. Yeah, this is really amazing. It's really amazing work. Yeah, and one thing that I saw at the end of your slide in conclusion or future work, I guess, in spring semester you are planning, there is cyanobacteria you mentioned at the end. So that is my dissertation work, and we are right now investigating, some cyanobacteria in Botswana. There are so many elephants died in 2019. So I was just curious, did you see any change in movement trend in your data analysis in 2019, during dry season especially?
That's a great question. Yeah.
Go ahead, Johnny.
Well, first of all, thank you for those kind words as well. Cyanobacteria is something that came up as we were doing our research, actually, because there was a big event that took place and some elephants were affected by cyanobacteria. So that was something that we did not actually include in our analysis, but it was a talking point throughout the term. So we weren't able to really quantify the effects of cyanobacteria on elephant movement, but that's definitely something that could be revisited. And the fact that we have another term working on this is something that we want to push forward as well.
Yeah, your data is really useful for that research, the future term, it will be really useful for the team, I think, the next term. And one thing, the PlanetScope data you are going to use, for example, in next term, the problem is for cyanobacteria, you need a specific band configuration, which is 620 nanometer, and that you cannot find in that PlanetScope. Okay, so for that, I think you can use the Sentinel-3 data, which is at 300-meter resolution, but you will have that particular band to identify, because there will be different algae bloom. To identify cyanobacteria, you need that particular band.
Good to know. And are you a student at UGA? Really?
Yeah, I am a Develop alumni as well. So I did 5
awesome.
times or 6 times. I don't know. So many
That's
times.
Great.
Yeah.
I think your insights
That's
will be very
awesome.
helpful for next semester or next
Yeah,
term.
yeah. I will be here, I think, at least for next semester. After that, I'm graduating, so yeah, I will be here.
Abhishek is
Amazing.
the smartest person I know,
Thank
without a
you.
doubt.
Develop
Best
this.
developed team lead ever.
Amazing.
We're gonna have the next term reach out to you for some
Yeah, sure.
insights.
Yeah.
Well,
Yeah, Abhishek, when I saw your presentation, I said, oh, Sentinel-3, that's what we need. So I wrote you down. So we'll
Yeah.
definitely be checking in with you for sure.